Now in this small video we discuss the combination of slabs, or what you say, the composite wall arrangement. So if two walls are connected like this, two connecting slabs are connected like this, and the heat energy is flowing from left to right, at steady state we can find that the same heat current is flowing through both the slabs. At the same heat current is flowing through both the slabs, you can compare the same thing with the electrical conduction through what you call two resistances. Okay, you can compare this with the. So when the resistances are R1 and R2, and the same current flows through this both the resistance, then the resistance are said to be in series, and therefore you can see that the effective resistance will be equal to R1 plus R. The same is applicable here also, because the heat current through both are found to be the same. Then, from the equation for thermal resistance, we can have R effective for thermal resistance. I am taking R for thermal resistance. So, that will be equal to X1 by K1 into E plus X2 by K2 into E. I am getting. So, both the slabs are in series. The resistance are coming in series, and it will be like this. And if I take that together as this one together, I can compare this with what you call X divided by K into E. That will be equal to X1 by K1A plus X2 by K2E. Now where this X is nothing but the total length of that conducting slab, and K I can take it as the effective conductivity of the slab. Then approximately from this one I can have the effective conductivity compared to the X and A, like I can take it as X1 plus X2 divided by K into E will be equal to X1 K1E plus X2 K2E. So effectively what I am getting is, there is a proportion connecting this K1 and K2 that comes as reciprocal of the conductivities. Alright? And if you want to get the exact condition here, if this this A value is same for both, and therefore if I assume this is the case with the condition, and if I take X1 is equal to X2, right? If X1 is equal to X2 equal to X, if I fix for this case, what I am getting is 2x divided by k into a will be equal to x by k1a plus x by k2a. I get. So a is remaining constant, and x, what you are getting as 2 by k is equal to 1 by k1 plus 1 by k2. So, when the slabs are arranged in series, the conductivities are coming according to this condition, and this is, if I fix this condition, then I will be getting an exact number like this for the conductivities when the slabs are in series. Okay? Now, if I get, or if I take the slabs are connected in parallel, if the slabs are in parallel, I mean, if I connect them like this, slab 1 and attached to that slab 2. Something like this. Area of cross section is also different. Okay. Something like this. Or else I can take the length to be the same for the time being. It's an approximation. Here for the first one, area of cross section is A1. For the second one, let it be A2. Area of cross section. And length for the time being, let it be X. And here it is theta 1 and here it is theta 2. And a heat current is flowing from here into it, heat current. So as the heat current is flowing from left to right like this, theta 1 is greater than theta 2. Then for this particular heat current, actually as the current reaches here, the heat current is getting split. One part goes through the upper side and the other part will be going through the lower side. As you see, the parallel combination of resistances. So one part resistance is like this and the other part comes like this. Okay? And you can see that the heat current reaching here is getting split into two. So I can take the resistance of the path R1 and R2 as they are in parallel. So compared to this, I can write the equation for combination of resistances here as 1 by R effective will be equal to 1 by R1 plus 1 by R2 for parallel combination. 1 by X divided by K into A1 plus A2 will be equal to 1 by X by K1 A1 plus 1 by X by K2 A2. This is the format we are getting for parallel combination effective resistance. That means it is K into A1 plus A2 divided by X is equal to K1 A1 divided by X plus K2 A2 divided by X. So X being the same throughout, you can write K into A1 plus A2 will be equal to K1 A1 plus K2 A2. So I can fix the conditions of that A1 equal to A2 equal to A. Then accordingly I am getting the result. So I can fix this one for this particular case. And there can be cases that this X can also be changing, like X is equal to, this can be a little bit extended, and this is K1 and K2, and then X1 and X2 will be coming there. Then accordingly the equation varies. Okay? So when they are coming in parallel, the conditions of conductivity is coming as K equal to a kind of K1 plus K2. So conditions are to be varying according to this. So you cannot by heart them. You can by heart only one thing, that the resistances, when the slabs are in series, the resistance also comes in series. When the slabs are coming parallel like this to the flow of heat current, the resistance also comes in parallel. That is all you can remember, and accordingly you can obtain the equations.